Welcome, everyone. Thank you for joining us for today's webinar, Building an Efficient Data Architecture for Maximum Productivity. My name is Louise Westerby, and I'm a Director of Product Marketing here at Dremio. Before I introduce you to our speaker, I'd like to go over a little housekeeping before we begin. First of all, the webinar will be recorded, and it will be sent to you after it is recorded. If you have any questions during the presentation, please type them into the question box at any time. We will address the questions live during the Q&A session at the end of today's presentation. So with that, I would like to introduce our speaker, Tomer Sharon, one of Dremio's co-founders and our Chief Product Officer. In fact, this week, Tomer is actually celebrating 5 years at Dremio. Previously, Tomer was the Vice President of Product at MapR, where he was responsible for product strategy, roadmap, and new feature development. As a member of the executive team, he helped grow the company from 5 employees to over 300 employees and 1,000 enterprise customers. Prior to MapR, Tomer held multiple product management and engineering positions at Microsoft and IBM Research. So without further ado, I'll turn it over to Tomer.
All right, thanks, Louise. Thanks for that introduction. That was great. So the topic of today's webinar is all about increasing productivity, and specifically the productivity of data teams, so data engineers and data architects. And that is becoming increasingly important, especially in the current economic climate, where for a lot of companies, we're basically forced to do more with fewer people, or with the people we have. And so the amounts of data continue to grow, and the complexity of the environments continues to grow, but the size of our data team doesn't increase. So we'll talk today about what we're basically doing at Dremio to address that challenge and to make data engineers and data architects more efficient and more productive. So Louise provided some background. That's my picture, just so you know who you're looking at here. Just a few words about the company before we get started. We have a very large number of enterprise customers that we partner with, and that spans every vertical. So ranging from very large, some of the largest tech companies in the world, to many of the largest financial services firms, and everything in between. Train companies, airlines, alcohol manufacturers, CPG, energy companies, et cetera, et cetera. Along the way, we also created an open source project that many of you are probably familiar with, called Apache Arrow. And Apache Arrow really started as Dremio's internal memory format. We decided to open source that as an Apache project, with the idea that there was an industry standard representation of data on disk with things like Parquet and ORC, and that allows different systems and engines and tools to exchange data through disk, through storage. But there wasn't a standard for representing data in memory, especially in a high-performance columnar way. And so every database, every columnar database, every BI tool was using its own memory representations, and that leads to a lot of inefficiency. And so we created Arrow as a result, and contributed our own internal memory format, which has now become very pervasive. Over 13 million downloads a month in the last month, and every data scientist now uses Apache Arrow, whether they're in Python or R. The company has raised over $100 million, really top tier VCs, and most recently our Series C, another 70 million from Insight Partners in New York. So what do we mean by productivity when we talk about that? So I really think about this as two things, the efficiency and the effectiveness. So efficiency is the how do we reduce the cost and the effort of doing something, right? How do we do it with less people, less dollars, less time? And then effectiveness is how do we make sure we do the right thing? Because we can go through all this effort, and many data projects often end up that way, where we do all this work, and at the end of the day, we don't achieve the result that we want, right? In fact, I was talking to a very large company yesterday, and they were talking about how the complexity of just ingesting all the data and organizing it for their analysts takes so much time and so much effort that most analysts just give up and just don't leverage data. And so we have to make sure that we're also building the right infrastructure and the right pipeline and the right systems, so that people actually use the data, right, and use it easily. And so those two things, efficiency and effectiveness, really combine to what we call productivity. And that's what we focus on at Dremio. So everything we do here, we think about how are we going to make data teams, and by data teams, I mean data engineers and architects, more productive. How do we let them do more with less? And of course, the demands on them continue to grow with the data consumers, whether they're using Tableau, Power BI, Looker, Superset, or they're using more of a data science tool like a Jupyter Notebook. How do we make those people get what they want with minimal effort? So what's changed in the world I'd say in the last few years is the rise of data lake storage, and that's what really is providing us now an opportunity to kind of reimagine how we build data infrastructure. So when you think about where a lot of modern data is landing and where a lot of legacy data is landing when companies move to the cloud, it's really in these systems like S3 and Azure Storage, right, or ADLS. And the reason for that is that S3 is infinitely scalable. It's extremely inexpensive. It's something like $20 per terabyte for both Azure Storage and S3, and very easy to manage, right? It's always there. It's available in many different regions across the world. And so that's become effectively the default bit bucket in the cloud, right? That's where everybody's putting their data. You talk to somebody in the cloud, they're, well, yeah, my data's in S3. And today, oftentimes they move it to other places, but that fundamentally is kind of has become almost a system of record, I would say, in the cloud. And so what we've seen based on various data points and estimates is that the amount of data in S3 is growing over 100% year over year, and will continue to do that for the foreseeable future. So that's great. Now we're putting so much data in one place. Wouldn't it be nice if we could just, everybody could just leverage that data and have a magical experience, right? Ask any question at any time and get the answer that they want. Unfortunately, the things are a lot harder than that, right? And if you've tried to use a SQL engine like Presto or Hive or one of those things, or Athena, then I'm sure you've realize this experience, right? You put the SQL engine on top of the files and you expose it to the Tableau user, let's say, Power BI user, and they have a terrible experience. And the performance is different every time they run the same query. The dashboard takes many minutes to load, and nobody wants to use the system, right? So of course that doesn't work for most companies. And so when we talk to companies that have tried kind of one of those generation one, SQL engines like Presto or Athena, et cetera, what you see is that they're not able to make this work, and instead they end up building something like this, right? So you take the data that you have in S3, which wasn't it nice that it was all in one place, but you couldn't get the performance on that, and it was also maybe too technical, too complicated. So you move a subset of that data into a data warehouse. And that could be a variety of different technologies, just 3 examples here, right? Redshift, Snowflake, Teradata on this slide. But in reality, lots of different options here. Could be just a Postgres database, an Oracle database, could be many different things. Fundamentally, that's kind of that data warehouse. And of course, you can only move a small subset of your data into that system for obvious cost and scale reasons. Building this pipeline, this ETL, is extremely difficult, and it's not just building it, but it's also keeping it running so that when you come in every morning, you don't have a bunch of analysts screaming that it didn't get refreshed that night because of some issue. And then oftentimes beyond just these systems, you still can't get the interactive speed that the user wants in terms of their dashboards or their ad hoc analysis. And then you see companies using cubes, you see them using Tableau extracts, you see them using aggregation tables, data marts, right? So all these different systems where you might further pre-aggregate or consolidate kind of data so that finally the user at the top here has the experience that they want to have, right? The very fast queries or very fast dashboards on a small kind of sliver of data in this case. And of course, the problem with this is that it's a huge effort, right? Building this thing for a data engineering team is extremely complicated, and it's generally not general purpose either. So you're basically creating a cube for a specific use case, or managing extracts for a specific user or a specific set of users. But of course, those users then they want something else, and maybe a new user comes on board, a new analyst, and they want something different. And so while this picture may look like it's some kind of generic infrastructure, in reality, it's a lot of ad hoc kind of one-off work that has to be done to satisfy each of these business analysts and each of these data scientists, which of course is very inefficient and also very frustrating for data teams, right? You want to be working on much more strategic work and really providing much higher value for the broader organization, as opposed to kind of doing one-off tasks for individual users. So this is, by definition, not very productive, right? Maybe you're providing the performance that somebody needs at the end of all this, but even then you don't have the agility and the flexibility for that user, because they want to join what's in that cube with that other big data set that you have in S3, and they can't do it on their own, and they can't join the two cubes, and so many different restrictions and limitations when they're kind of looking at data through a straw. So and that's what we mean here when we say decreasing data scope and flexibility, right? At every stage in this kind of pyramid here, the amount of data is smaller and more siloed. So you lose that amazing property of things like S3 and ADLS, where you have this centralized store with so much data that you just want to be able to have really, really fast queries on. So as a result of this architecture, we have a huge productivity problem for data teams, right? For data engineers, which is actually what we were looking to solve with the rise of that kind of centralized, inexpensive and pervasive object storage. So the challenges here are that you have this inefficient architecture that's really time consuming to maintain. Every request for new data or a change in many cases takes weeks or months to address. And we have lots of examples of companies across all verticals where things were taking 3 weeks, 2 months to address new requirements, new changes to dashboards, things like that. And then finally, data teams are overwhelmed with just meeting the demand and the need of all these different analysts, right? And typically the analysts outnumber the data engineers by an order of magnitude at least. So the result of that is really low productivity and also very high time to insight. And so I love this quote. This is a recent blog post. You should definitely read that. It's on the Werner Vogel's, that he's the CTO of Amazon, and not just AWS, but Amazon in general. And he has a blog, and you can read about kind of how they're thinking about data lakes at Amazon for the whole company there. And one of the quotes there, one of the things he said in that blog post was that if you wanted to combine all this data in a traditional data warehouse, right, something like a Redshift, Snowflake, etc., without a data lake, you would have to do a lot of data prep and ETL work, right? And you would have to make trade-offs on what to keep and what to lose, and you're continually changing the structure of a very rigid system, right? And we've all been through this problem in several decades of kind of dealing with data warehouses, right? On top of kind of the lock-in, and you can't even get off of it at the end of that. So obviously not a great story there. We think the solution here is a new type of technology. And we're calling that technology a data lake engine, right? A new kind of compute engine, effectively, that runs in your cloud data lake. So you think about cloud data lake, there's that centralized storage system, S3 ADLS, and then you have that separation of compute and storage where you're running, you may be running Dremio, you may be running Databricks, you may be running Athena, lots of different things that you can run on that same data. So that to us is a cloud data lake. But we think that there has to be a new kind of data lake engine in order to really make this work, and in order for data teams to be productive and not get bogged down in the never-ending stream of requests from analysts. So what does this new category or new type of technology have to do, right, in our mind? And these are the things, of course, that we've built and continue to build. So the first thing is being able to have really fast SQL-based access to data lake storage. It can't be like, the old world where I set up a Presto cluster, an Athena environment, and I just get really slow queries and everybody gets frustrated and starts creating Tableau extracts, right? So it has to be much faster than that. There has to be a query acceleration component where if just the physics are not possible in terms of scanning the entire data set and still getting an interactive response time at a reasonable cost, then there has to be a way in which data can be kind of organized and structured to make it fast, right? And that has to be part of the system and very transparent. There has to be a separation between the logical data sets and the physical structure of the data, right? The physical structure meaning, these are the Parquet files I have, this is how they're partitioned. And by logical, I mean virtual data sets, different users have maybe different views of the data based on their security kind of credentials and so forth. So that's the logical data model, or the semantic layer, right? It's providing consistent KPIs and consistent security for all users. It has to be able to also connect to other external data sources. So while a lot of the world's data is moving into systems like S3 and ADLS, a lot of data still remains in other systems, whether it's Postgres, MySQL, SQL Server, Oracle, and so forth, right? And of course, data warehouses as well. So this system has to be able to, for example, perform a join between, maybe a smaller table that you might have in Redshift or SQL Server, and maybe something that a very large data set that you might have in S3 or multiple data sets. You have to be able to provide really fine-grained access control down to the row and the column level, because these days it's really the norm that different users are supposed to see different views of the data. Maybe one user can see it masked and another user sees it unmasked. And then finally, kind of it has to work for different teams and different groups and provide workload isolation so that a data scientist running some exploratory work is not causing interference for an executive dashboard, right, which has to load in 1 second or less. So that workload isolation is really important. It's also why you see challenges, I think, with a lot of the serverless solutions that are out there, because they can't provide that isolation. And so one time your dashboard takes a second, and then the next day it takes a minute because some queries got queued up in behind some other work. And then it has to take advantage of the cloud. Really, it has to be built for the cloud. And what I mean by that is it can't be just like one big cluster, 100 node cluster that maybe is elastic and add and remove nodes, but it is basically kind of designed for Hadoop, right? It has to be really built for a cloud environment like AWS or Azure, where instances can be rented, machines can be rented by the minute, right? And so the engine should be able to take advantage of that property and be designed for that, right? As opposed to designed for a very large Hadoop cluster, for example, and kind of port it to the cloud. So Dremio is a data lake engine, and we focus on a few different things here. One of them being improving productivity, and the other being reducing cost and risk. So when it comes to improving productivity, if you remember that picture that I showed you just a few slides ago here, we need to be able to get rid of this light gray part of the stack here, right? Because if you already have data in S3, you should be able to query that data in S3, and you should not have to move it to other systems just in order to get the performance that some users want, right? So in order to do that, we have to be able to provide the performance that people expect, not only with data warehouses, but with cubes and extracts and all these types of systems that people are using, were using in the past to manually kind of provide query acceleration. And so what you see with Dremio, if you compare it to something, say like Presto or one of those types of SQL engines, is that you're getting orders of magnitude faster performance on your BI dashboards, right? And that's because of a number of different things that I'll talk about in a second. But one of the key ones there is data reflections. A second important thing here is, even for the ad hoc query, when I'm doing some exploratory work, providing a 4x performance advantage over kind of typical query engines, just normal query engines. Just by being more efficient, right? Taking advantage of the Intel CPU better and leveraging Apache Arrow and code generation through LLVM, right? So that's what you mean by ad hoc query speed. And then really being able to provision new data sets fast, because at the end of the day, analysts are going to want new things. They're going to come to the data team and say, I need this data set. And if we can provide a platform here that you can provision a new data set without creating yet another copy of the data that you are going to have to maintain and keep in sync with everything else, if we can do that 100 times faster, instead of 3 weeks, maybe it's minutes, then that's of course a huge productivity improvement. Okay, so that's what we mean by improved productivity. It's getting rid of that complex ETL stack that we saw a minute ago. And then, of course, the cost and risk have to be extremely low, right? And so we're constantly focused on improving, the infrastructure cost, if you will, right? So the amount that you're going to end up paying every month to Amazon or to Microsoft for the infrastructure, right? And it's in this era where everybody's kind of really looking at their cloud costs, and that's one of the hardest things to control. You want to use systems that are designed to minimize that cost, right? If something's not running in the system, you shouldn't be paying for the infrastructure, and I'll talk more about that. And then finally, one of the things that we're huge believers in is avoiding vendor lock-in, right? That's why we we have this allergic reaction to leveraging data warehouses to speed things up, because we've all seen in the past data warehouses where we've gotten locked into them. Prices continue to go up, they're really expensive, and you're basically stuck, right? And so that's not the approach we believe in. In fact, by having the data in an open format like open source formats in S3 or ADLS, today you can use Spark, Databricks, Dremio, Athena, other things, and then who knows, in 2 years there'll be some other technology you'll be able to use as well, right? So that this approach is really powerful in that regard. So how do we do this? How do we get this kind of performance, right? And it comes down to a number of different technologies really playing together here. So if you look at the left-hand side of this slide, what you see is kind of those technologies, and it starts with basically having these predictive high-performance parallel readers from the systems like S3 and ADLS. So we're never waiting to get a response. It's not request response like most systems. It's actually you're getting a constant stream into the engine of data from S3. On top of that, we wanted to provide the performance of NVMe combined with the cost and the scalability of S3, right? And so what we've created is this thing called C3, which is our columnar cloud cache. It's effectively a distributed cache that you do not have to manage. You don't have to. You will not even, unless you try hard, you won't even be aware that it exists, other than the fact that the second time something is accessed from your S3 bucket, it will not have to get fetched again from S3. So it will already be sitting in the cache, and you'll get much faster storage per IO performance, and you'll also eliminate the cost of doing the gets and puts to S3, which tend to be about 10, 15, 20% of the amortized cost of a query. The next layer here is data reflections. So data reflections are basically when you can't get the performance that you need, like for that dashboard, that executive dashboard, that where the users want 1,000 concurrent queries or 100 concurrent queries, and they want it to be sub 1 second, and there's just no way to do that if you're going to scan billions of records for every query. This is where data reflections come in, and they allow you to have the data aggregated and sorted in different ways and partitioned perhaps, and the optimizer automatically takes advantage of that when new queries come in. So these are never exposed to the user. The user is just working with the logical data sets. Data reflections are basically kind of like indexes. They're coming in behind the scenes, and you can very easily add or remove them over time. The system even provides recommendations. And then on top of that, if you look at here at the Apache Arrow is the foundation of Dremio. That's the core engine. There's a project called Gandiva, which you can look at in the Arrow project, which we've built, that takes advantage of LLVM to basically compile SQL expressions into native code that can take advantage of Intel's SIMD or AMD's SIMD instructions, right? Parallel, basically vectorizing execution in the CPU. And then finally, Arrow Flight is a way that another technology. The idea here is as a replacement for ODBC and JDBC for data science use cases. So all those users are already using PyArrow, for example, in the Python world, and so giving them a way to very quickly get the data without going through ODBC and JDBC. And this is something like 50 times faster than like an ODBC type approach. So the idea here is provide much faster performance to the client. So that's kind of the performance. How do you get the performance? You don't have to build that really complex stack, but we also have to solve this problem of data consumability, right? So as users are asking for new data sets and they're wanting to derive from maybe the IT approved data sets, to derive some other kind of derivation and analyze that, right? Maybe they're it's as simple as cleaning some column names. Maybe it's more complex of doing some data prep. Maybe it's joining different things, all those types of things. We want to enable you to do that with a kind of a virtualized approach, right? Meaning create virtual data sets or views as opposed to creating physical data sets. And this ties really elegantly with those reflections I talked about earlier, because you want the performance, but you want to be able to work in virtual data sets. And so the semantic layer in Dremio allows you to have virtual data sets. They're organized in spaces, and they allow you to both provide kind of consistent KPIs and business logic to users. So you can have a virtual data set that encompasses that. And then it also allows data engineering teams to provide kind of security, kind of a security layer on top of the raw data. So maybe the data scientists or the engineers, you want them to be able to access the raw Hive tables, right? The raw glue tables. But you might not want to give that access to everybody. And so you can use a semantic layer also to provide more granular control and different views into the data for different users and groups that you might have in, whether through OAuth or LDAP. And so the end result of all these capabilities, and I'll show you a demo here, is that you can get much faster time to insight, right? You're basically, this is what I talk about in terms of both time to insight, but also kind of productivity, right? If the time that it takes to do all that work is just really long, it's a lot of work, a lot of manual work that data engineers have to do, kind of using traditional approaches where you're moving data between many different systems. If you don't have to do that, you can drastically increase the time that it takes, decrease the time that it takes to make data accessible to users. So let's jump into just a quick demo here, just to show you what I'm talking about. So this is a very simple, very small cluster that I've got running here in the cloud, of course, and we use this for demos, so it's maybe not a great example in that right now we're actually connected with a single environment to Amazon, Azure, some on-prem stuff. So it's all kind of a little bit all over the place. What you can see here is that these are our data sources. I can connect directly to like S3 and query files and directories of files, or I can go connect to like my Glue or Hive Metastore catalogs and leverage that as well. I can of course connect to many different things. So that's the data sources. Then we have spaces. This is where the semantic layer lives. So for the purpose of this demo, let's just go and create a space called the webinar space, okay? So you can see there's nothing in it, of course. I literally just created that. That's kind of like a folder effectively. And every user also has their own personal space. So I got some weather data here that I've created. I've brought in just a CSV that I downloaded online, and I've created some virtual data sets myself. Those are the green ones that you see here. So I might do something really simple. Let's start with some simple example. You may have seen this data set before of New York City taxi trips. It's one of my favorite data sets because it's relatively big and interesting to kind of observe. So if we drill into kind of the business transportation here and NYC trips, what you'll see here is a data set that has about 1 billion taxi trips that happened in New York. I think this is from around 5 years ago, really. So you have a vendor ID, you have a pickup time, you have a drop-off time, the number of passengers, the trip distance in miles, and a variety of other things. So you know, we can open this up. I'm running on a Mac right now, so I'm going to use Tableau, which works on my Mac. But we have very nice integration with a variety of tools like Power BI and Tableau, Looker, etc. Superset's another open source one. All right, so what I'm going to do is I'm going to let me show you a simple, just kind of let's count how many records we have here. So you can see we have about 1.025 billion records, and this is a very, very small cluster. It's kind of for demo reasons. So let's see what year they happened. All right, so we have about 162, 169 million, 170 million taxi trips per year. Maybe we want to look at it by see if there's any weekly patterns here. So let's look at it by week. So it's interesting. Some weeks are end of February, low week in terms of number of taxi trips. And let's look at the trip distance and see if there's any patterns in the trip distance. So let's change that to an average, because that is probably more interesting than the total distance that people traveled that year. And actually, it's interesting. You kind of see this upward trend from 2009 to 2014. I guess the taxi trips got a little bit longer. And I don't know exactly why that is, but what I want to show you here is just the performance, right? This is querying the data lake and providing interactive response time that, of course, you couldn't achieve using a SQL engine, right? Or just say a generation 1 SQL engine, something like a Presto, right? Now, sometimes this data set is not exactly what the user needs, right? And so if you remember, we created that space earlier in the demo called webinar. So what I'm going to do is let's imagine I want to look at the trip distance in kilometers instead of miles. So I can go and create a calculated field called trip distance, and in kilometers, just multiply the miles by 1.6. We'll keep it simple. So let's accept that. Oh, yeah. Let's click on that. And And what I should show you actually is, I think most of our users actually use they like the SQL interface. So you can do some things in the UI, but really, if you know SQL, you can use any select any ANSI SQL statement here. So that's all I really did here was alias the multiplication of the miles by 1.6 as kilometers. And I'm going to save this virtual data set, and we're going to save that in the webinar space. So we're going to call this the taxi kilometers, right? So now we have this webinar.taxikm data set. If I go to the webinar space, remember that one? We have taxikm. It's a new virtual data set, right? That you see the green icon. You can actually look at the graph here and see, well, this data set is derived from this data set, which if I click on that, that moves to the middle, and you can see all the things that were derived from that one. So kind of interesting way to look at that relationship between all the different virtual data sets and kind of the physical data sets. And if I go back to my Tableau here, what you can see, I think it was called taxikm. I'll search for that, and you can see we have this new data set called webinar.taxikm. So if I drag that here, what you'll see is I can now use the trip distance in kilometer field or measure in Tableau lingo. Drag that here and change that to an average. And you can see I'm getting the same response time, right? And so the reason I was getting, I mean, for many reasons, I was getting really fast response time on the original data set, but even for this new data set that I literally just created, I'm getting that same kind of response time. So what's actually happening behind the scenes here is we had data reflections that have various aggregations on this data set. In this case, just the automatically recommended ones, but those same reflections are being used not just for the that specific data set that they were associated with, but actually even for this new derived data set that I just created. Right, so you may have hundreds of data sets in the system here, and they're all leveraging that same physical kind of indexes, these same reflections to accelerate queries. And the user, of course, doesn't know about these data structures. The user is always dealing with kind of the semantic layer, these virtual data sets, or the physical data sets that they might have inside of their data lake, for example, just the folders of files or the glue tables and so forth. All right, so that's a very, very simple example. And in the interest of time, let's keep going here. We show you a lot of different things, how you join S3 and Postgres and so forth. But I do want to leave a little bit of time here for Q&A. So we talked about how you get productivity in terms of making data accessible to the analysts and even the data scientists really quickly. So you're not having to move it between all these different systems. But I think one of the other really important things is making sure that we're efficient, not just in our time and in how much a person on the data team can actually get done, but that we're also efficient in terms of our dollars, right, and how much we're spending to get to this kind of really good solution for the analyst, really low time to insight. And one of the key capabilities here, if you look at our new AWS edition, is we've really re-architected the system from the ground up, so that rather than having one cluster, it's no longer like that. You basically, a Dremio cluster, a Dremio environment now is it consists of many different engines, right? So traditionally, you think about like all these big data engines, Hive, Presto, etc. You have a cluster, right? And you have all these different workloads running on that one cluster. You have your executive dashboards, your financial analysis, your marketing team is running ad hoc queries, some interns are working on the weekend, all running in one cluster and impacting the runtime of different queries and potentially even causing queries to not complete successfully. And so that's a really bad situation to be in, and one of the reasons that I think a lot of engines that run on data lakes didn't really work well. And what we've done is we've kind of rethought that from the ground up and created this world of multiple engines. So the idea here is that different users, different groups, different workloads can run on different engines. I might have a medium-sized engine for my weekday queries, and I might have an extra large engine for the marketing analysis and so forth, right? I can have different sizes of engines for different workloads, and when no query is running in that workload, that engine is off. You're not paying anything to the cloud provider. There's no infrastructure cost for that. So this separation is really taking advantage of the fact that in the cloud, we can rent hardware by the minute, right? We can go to Amazon, or even by the second. We can go to Amazon and say, hey, give me 100 nodes for 10 seconds, right? And that's something that on-prem, that was never possible, right? So engines on-prem, kind of query engines, Hive, Presto, etc., were just not designed for this, right? But in the cloud, you want to take advantage of that property, right? And so that's what happens. And you can actually map different workloads based on the LDAP user and group, based on the time of day, based on the estimated cost of the query that the optimizer comes up with. You can basically create your own rules, your own definitions of how do I route that query to an engine. And then of course you can also you might say in the Tableau dashboard, in the Power BI dashboard itself, you might say use this specific engine, right, through just kind of the ODBC setting. So that's the Elastic Engines. What's really important here is it provides the workload isolation so you can achieve what you need. But in terms of cost saving, in the past, you would have had to size your cluster based on your peak workload. And because auto scaling a single cluster, it just never works well. For various reasons, just doesn't give you what you want. You kind of had to size the cluster for the most part to meet the peak workload, right? If Monday at noon was your peak workload, you had everything running at the same time, you needed your cluster to be able to handle that spike really quickly, right? And so you were paying for a lot of idle capacity in these clusters, right? That's kind of how things were working. So that's this light gray rectangle you see here on the left. The x-axis is time, and the y-axis is the workload. Today, now with Elastic Engines, because you can size each engine to that specific workload, and that engine is not even running when that workload is not running, you're basically only paying for the gray area that you see in the chart here. So that's in all the cases that we've analyzed, or the vast majority of them, more than a 60% cost reduction in your cloud infrastructure cost. So this example here is, this orange color is a small, weekly financial reports. So it's just running once a week. These are nightly jobs, the blue ones. So that's running just every night. And then you have this weekend workload. And so now you're only paying for basically what you're using, which is, of course, what we want. And then finally, just administration, right? Nobody wants to adopt a new tool or a new technology, new platform that is really hard to maintain, really hard to install. You got to configure it and all that kind of stuff, right? And so what we've done here, we wanted to maintain that benefit of being able to run inside your AWS account. So you're not kind of giving your data to us, right? But we wanted to give you that really easy experience. And so what we do is we have, basically, if you go through the AWS Marketplace, you click a single button and the coordinator comes up. You have that user interface there, and you can basically get started. Everything is pre-configured, the instance types, the memory settings, the C3 cache is already there. You basically don't have to worry about that. In fact, the system is automatically being backed up. With a single click, you can restore from that backup like it was yesterday or a week ago. And then the upgrades are as simple as bringing it down, bringing it up again, and it will have the new version. So it really drastically simplifies all the kind of the administration around having one of these data lake engines. So you can actually try that out. You can go on the Amazon Marketplace. So with that, I'm going to wrap up here and open this up to questions if there are any questions here. Just to kind of summarize, we felt that there was a need for a new type of query engine, new type of that was really designed for the cloud, right? At the end of the day, and could give you the performance, the productivity that basically you need in order to make the company data driven, right? Because traditionally, if you were to ETL all the data into data warehouses, go build cubes, extracts, data marts, all those types of things, not only would you have a really long time to insight, right? Maybe you'd spend a month every time somebody wanted to change, but you'd constantly be in this reactive mode as a data team, as a data engineering team. You'd constantly be reacting to tickets. And so we want to help companies get away from that. And we're doing that with a lot of really innovative companies, tech companies, financial services, etc. Yeah, we would be really happy to answer any questions that you have. So last thing I'll say before we go into Q&A here is that yeah, you can try this out. It's actually the Dremio AWS edition is free. So we, of course, if you want the kind of the advanced security features and the support, then that's with our enterprise edition. But you can actually go to the marketplace today and spin this up. And you can reach out to me if you have any questions. You can also go on our forums. So we have the community forums where you can actually ask any technical question and get a quick answer. All right.
All right, thank you, Tomer. So we'll go ahead and take some time for some questions. Be sure to type your questions in the question box in your control panel so that we can address them to Tomer. We received a number of questions in the Q&A, and if we don't have a time to address them all at the end, we will follow up directly with you after the webinar to address them. So Tomer, the first question is a bit of a long one, but I think it's worth, got some good clarifying points in there. The question is, can you throw more light on whether Dremio can act as a data pipeline for making data reflections? What I mean is getting data from different Oracle databases and tables, doing complex aggregations, saving the results as Parquet file on the Cloudera HDFS cluster, and making these data sets available as data reflections in Dremio for huge data sets, so a few terabytes in size. Is Dremio performant enough for doing this, or does it still need ETL pipeline?
Mm-hmm. Yeah, I think the answer to that is I would be hesitant to do that for very, very large tables, and it's not really a function of the Dremio's performance. It's really how fast can you get data from Oracle, right? Because if it's going to take you know, hours to get the data from an Oracle table that has 100 maybe hundreds of millions, or actually maybe many billion records, that could take a long time, right? So we do have connectors for Oracle and other relational databases, and we have many customers that use reflections to cache that data. If the data is append only, meaning the table is constantly being appended to, then I think that's going to work a lot better, right? Because then you can use incremental refreshes of the reflections, and that will work a lot better. So I guess the answer is a little bit, it depends on your use case. But yeah, feel free to follow up with us more, and we can look at the specific details of your Oracle tables and how they're getting updated, and to give you a better answer. So it may or may not work well.
Okay, thanks, Tomer. Another reflections question. Isn't reflections just a synonym for data cubes / marts, with the only difference is that we're not writing any ETL code to build them? We still have a processing time in building a cube or building a reflection.
Yeah, it's a great question. The answer is no, it's not similar. I mean, I guess there is some similarity, right? Like cubes, indexes. I mean, at the end of the day, that's, you're creating a different data structure that's more efficient for running a query, right? Like the same thing when you query the web through Google, they're not scanning every web page, right? They've created various indexes. So yes, it is a data structure that can help accelerate queries. But with cubes, typically what happens is the user, the BI user is connecting to a cube, right? The BI user is aware of the cube. If the BI user needs something else, you have to change the cube. If you change the cube, you have to tell the BI users, right? They have to update all their dashboards. With reflections, they're never exposed to the user, right? The user who's running the query is not aware of the reflections, and they're basically querying the physical and logical data sets in the system. And then behind the scenes, the optimizer is rewriting the query plan automatically to leverage those reflections. So the idea there is that when you start with Dremio, you probably shouldn't even create any reflections just to start. You should just start with Dremio, run some queries. You'll see it's a lot faster than other SQL engines, and then as you realize that you need things, right, you can create those reflections. You're not going to have to change anything in your client application. You're not going to have to change your BI dashboards or point to anything specific. The queries are just going to get faster because the reflection now exists behind the scenes.
Okay, thanks, Tomer. Next question. How does Dremio handle the case when source data in S3 is updated / reloaded? Will reflections update automatically and incrementally?
Yeah, so there are actually two update models. There's kind of a full refresh and an incremental refresh. And so when it comes to S3, one of the ways you can do incremental is based on new files. So as new files are being dropped into the let's say the folder in S3 or the bucket, then the reflection will get refreshed based on the new data that was added to that. For sources that are more tabular, like not based on files, that's where we would use like an updated at or some monotonically increasing column that exists in the data set to identify what the new records are for the incremental refresh.
Next question, does Dremio support infrastructure as compared to code approach for logical data sets, reflections, etc.?
Can you repeat that question again?
Sure. Does Dremio support infrastructure as compared to code approach for logical data sets, reflections, etc.?
Yeah, I think probably the question was infrastructure as code, or yeah, so more around kind of CI, like CI/CD kind of management of that. So
I'm interpreting it, yeah.
Yeah, I think that my guess is that was the question. And so yeah, all the virtual data sets and things like that in Dremio are basically updated through a set of REST APIs, right? The UI uses the same REST APIs that you could use. And we actually have some tools. In fact, there's one tool called Dremio CI, for short for continuous integration, that we've developed an external tool that you'd want to reach out to us. We can point you to that. And that tool basically allows you to kind of check in your virtual data sets into like Git or GitHub, and then kind of push them into the cluster and make changes. So a lot of our customers, they prefer to have all this information, for example, checked into like a version control system like Git, and then kind of push it out into the cluster, right? Sometimes they use that also for multiple clusters, dev, test, staging, that kind of thing.
Thank you. Does Dremio handle snapshot isolation or serializable isolation when data is being modified in Data Lake?
So the question is about transactional updates of data. So we just for everybody's benefit, I guess, one of the things that is changing in the world of data lakes is the rise of kind of these transactional table formats. The first one was actually Hive ORC tables, Hive Acid, which Dremio supports, and you can use that to do transactions. But two more modern ones I think that are very interesting are Delta Lake and Iceberg, Apache Iceberg. Iceberg specifically being backed by Netflix and Apple and Expedia and many of the large web companies are behind that one. And something we're very excited about. We're actually excited about both of these, and we have that in preview right now. So if that's something you're interested in, then please reach out to us.
Okay, thank you. There's a question about the free edition and how long it lasts.
Yeah, it lasts for as long as you last, I guess. It's not limited in time, so you can. There's no time restriction on the free edition. It's the difference between the free edition and the enterprise edition is really just kind of the access control. So who sees what data, and more advanced kind of authentication like LDAP and OAuth, and then of course kind of the enterprise 24/7 support. So the free edition doesn't have that, but yeah, feel free to use it. We folks use it in production, and we're very happy to learn about that use case. So okay. Let us know.
All right. How about data reflections refresh? How often can it happen? Types of incremental refresh.
Yeah, I'd say it's really up to you. You can configure it. I think our recommendation is to kind of look at something like probably 15 minutes or an hour. But we also have a lot of folks that prefer to do it on demand. So maybe if you're ingesting data into your data lake every night at 2 a.m., maybe you want to trigger it after that's run. So you can also do it that way, where you don't have to do it on a schedule. You can actually do it kind of on demand as part of some other pipeline that you might have. There's also something I should mention called external reflections. External reflections, basically, that's a way for you to create your own reflection outside of Dremio. So you might, for example, say, you know what, I'm already creating an aggregation on this taxi data set by these various dimensions, and I'm doing that in Spark, or I'm using Informatica and doing that unrelated to Dremio, and I'm storing that in a S3 bucket, or I'm storing that in an Oracle table. So you can actually register that data set, that aggregation with our optimizer through an API call and say that that data set represents this aggregation on this other data set in Dremio, and then the optimizer will leverage that. And so that gives you a ton of flexibility in terms of how you're updating, when you're updating, what exactly you're doing. Of course, you got to make sure the data's right if you're doing it yourself, right? Just make sure you're creating the right thing. So maybe test it once or twice, but that's also a way that you can do it if you need more flexibility.
Okay, thanks. There's a couple of questions, Tomer, about the availability of Elastic engines, whether it's available on Azure and as part of the enterprise product.
It's not available on Azure yet. It is available for both the enterprise and the community product, so you can actually use it on. It's part of the AWS edition. So the way to get started there is actually go through the Amazon Marketplace. It's a free listing. You can just get started that way. Yeah, you should be able to take advantage of it.
Great.
And yeah, actually, just this morning we released our 4.5 release, which has more enhancements to that, and we're just waiting on that to be updated in the marketplace listing. So within another day or two, be another update. Yeah.
Awesome. Can you talk about DevOps integration for code promotion, building pipelines, integration with Dremio?
Mm-hmm. Yeah, I think that's very common now. Everybody's using, like I said, CI/CD. Maybe not everybody, but a lot of companies prefer that route because, for obvious reasons, things are reproducible and very easy to test. So that whole kind of microservices architecture too has become extremely popular. And so that's what we see a lot of people doing with Dremio. And like I said, we have some specific tools that make it very easy to do that. So just reach out to us if that's of specific interest. Beyond just, of course, you can use the APIs and script anything in Dremio.
Yeah. Next question. I'm getting a lot of them here. Great questions. When data increases on the data lake, that in turn will increase the size of the reflections on an incremental update. If more nodes are added to the cluster, will it redistribute, or would we need to do a full refresh?
Yeah, so let me just clarify here. The data reflection actually is stored on S3. Let's just assume the Amazon example, right? Same thing is true for of course for Azure and even for on-prem. So the reflection is stored in the lake storage itself, which is why it's from a cost standpoint it's negligible. So there's no real concept of redistributing. So as soon as we create the reflection is updated, whether it's incremental update or a full update, you'll just have that new reflection in S3 and the old one will be discarded as soon as no active queries are using it. So yeah, if there is C3 in our is our column in our cloud cache, and yeah, that is really only a cache, right? And as soon as something changes, any changes to that data reflection, the byte ranges that have changed will be read from S3 and they'll be read in the correct place in the engine. So so you basically, it's something you don't even have to worry about. You're going to have maximal cache hits without having to do anything there.
Okay. Another question. How does Dremio work with the implemented in-memory database?
I'm not entirely sure I understand that question. Okay, so maybe this question is more about Apache Arrow because we use Arrow internally, and Arrow is kind of an in-memory representation of data, right? As I mentioned in the beginning, we are the creators of Apache Arrow, and Arrow is it's a columnar representation of data. So in the same way that Parquet is a on-disk columnar representation, Apache Arrow is a in-memory columnar representation. And there's a lot of things that make it designed for kind of in-memory. For example, having random access to bytes, right? Something you don't maybe get with Parquet, but you want to have here when you're doing execution on that data. And so that doesn't mean though that the data has to be in memory or that it's cached in memory, right? Even C3 is not in memory, it's on the NVMe that come with the EC2 instances or the Azure VMs. So Dremio is definitely not an in-memory database in that the data doesn't have to fit in memory, Of course, the more memory, the better, because queries run faster. You don't have to spill the disk; they're just going to finish faster, right? So you want to have the right amount of memory. And actually, in our Elastic engines, we allow you to choose a number of different instance types. Some are more skewed towards having more memory on them. Others are more CPU intensive. So for different workloads, you might choose a more CPU heavy engine versus a more memory heavy engine. And the idea there is, again, to optimize cost, right? Of course, you can have the engine be as big as you want, and so you can get any performance you want. It's just a question of, at what dollar amount. If the question was more about connecting to memory databases, then yeah, we connect to a variety of relational databases, and so it would be a question of whether that was one that we support. And there's actually some more interesting things coming there in the next few months.
Okay, next question. How do you handle updates to the source data in S3? How are the extracts refreshed? Lastly, how do I migrate the extracts out to another system? Does using extracts lead to lock-in? It's also a nice comment at the end. Thank you for the great talk.
Yeah, I think by extracts, they're talking about reflections here. So like I said earlier, start by thinking about Dremio without the reflections, right? Just as a very fast query engine, okay? So you can query the live data that you have on S3. And if you change something on S3, you added another file to that folder, or within the glue table, there's new S3 files underneath, then immediately the next query is going to pick that up. In fact, even with C3, which is the cloud columnar cache, which remember that leverages the local NVMe on the instances that Dremio is running on, even that doesn't affect the fact that you're getting live data, because with C3, we know on the S3 object that there's like a timestamp or a version number, so we know if it changed or not before we go and leverage the C3 for the kind of the cache representation. So C3 is never adding additional latency. So yeah, you can. There's no extract. We're not taking the data from S3 and putting it inside of Dremio or something like that. It's not a data warehouse, right? The reflections themselves are, like a materialized view or an index or a cube. They have to be built, right? They have to be refreshed. And so it's up to you what schedule you want to do it, when you want to do that. Yeah, there's no lock-in. The user's not connecting to the reflection. You could run tomorrow. You could just ignore that reflection, disable it, and everything's still going to work. Your Tableau dashboards will still work. They might be a little bit slower, right? I mean, if you were to move from Dremio to, say, another SQL engine, assuming it's standard compliant, it's ANSI compliant, you should be very easily able to move. Now, will things be slower? Of course, yeah, they'll be slower, but that's the nice thing here, is that you're not locked in, because none of the queries are referencing these reflections, right? You never query a reflection. It's entirely behind the scenes.
Okay, I think we have time for one last quick question. How can Dremio access data in a proprietary format that is not accessible via an SQL query?
There's two kinds of sources in Dremio, I guess. One is kind of more of one is a file format, and you can add new file formats to Dremio. You have to write some Java code for that. And then you can add also, if it's a relational database, we have a connector framework called ARP, Advanced Relational Pushdown, where you can connect and add new connectors to relational databases. I think we have some documentation online for that. So both of these things are possible, but we're probably light on documentation, I think, for how to add the file format. So please reach out if that's what you want to do. Reach out. Maybe we can schedule a session with kind of one of our architects or engineers and walk you through an example, one of the open source examples, and you can just kind of try to model it after that.
Okay. Thanks, Tomer. Unfortunately, we didn't get to everybody's questions today, and we are out of time. So we will follow up directly to those of you who didn't get their questions answered. We appreciate you being here. Please be sure to take a look at the AWS edition and give the Elastic Engines a try. Thank you again for joining us today, and we will see you next time.
Thank you.